I want to talk about how we can, one possible architecture and a set of tools and a set of things that we need to do to create an internal developer platform, right? Everybody knows what's internal developer platform? Cool. That's where developers go to click buttons. That's a simple explanation of it. So this is me, Viktor. I will not waste time on introduction because that's boring. I want to jump straight into the subject. And the subject is that there are certain things I want to do. And one of those things is I want to enable everybody to be autonomous. The worst thing that we can do is to wait for somebody else to do something so that we can continue doing whatever we are doing, right? That's how we waste most of the time in this industry. So the whole goal is to enable everybody to be able to do everything, right? Whatever that everything is. That can be, hey, you need a cluster? This is how you create a cluster. Don't call me, don't send me Jira tickets, don't send me SMS messages or whatever you're doing. No carrier pigeons in this company. This is how you do this, whatever that is something, right? And it's effectively really about inverting the direction of how we were operating in the past, right? Because traditionally in software companies, you have different groups of people, different experts, and they're all waiting for somebody to open a Jira ticket so that they can ignore it for a while. And then they will do it eventually, right? And it's normal because everybody's busy, right? Everybody has something else to do. And then you're waiting for something to happen. So today, by the way, developer platforms existed for decades, right? It's nothing new. It's just that we have now a new word for it, or 3 words, internal developer platform, right? That's the major change that you will take from this talk is that now we have a different name for the things that we were doing in the past. And it has very unfortunate acronym, IDP, which before somebody came up with internal developer platform meant identity provider, but with small d. Anyways, so what I'm going to do today is I will not talk much. I want to go hands-on right away. And I will try to do a few things, right, to accomplish certain flow. And that flow is that I want somebody to click a button, fill in a couple of fields, wait for a few moments, and then when something happened, we will get a new backend application, in this case, in today's demo, right? It could be anything. New backend application will be added to that interface, automatically appear. A new repository will be created for that new application because application code lives in code repositories, Git, not SVN. I will build a new image for that application because that's how we package and deploy applications today. I will update the manifest because we will use GitOps, right? So I will have a separate repository that will contain the desired state of my system, and part of that, clicking that button, will be that repository will be updated. It will say, hey, production now looks slightly different than before. The first release of the application will be deployed to production. Database will be created today in AWS, but the same story would be wherever you're running. I don't care. And from that moment on, after those, let's say, 20 minutes after clicking the button, all that anybody should need to do is just to push new code, right? Push new code, and then automatically things appear. They're deployed, they're tested, they're pushed to registry, they're scanned, whatever you're doing today, right? So that's the goal. Right now, let's. I promise that I will do the demo in 30 minutes. I will have to do it in 20 because I still didn't finish the introduction. The architecture of what I will try to do, and you need to understand that I understand that if you're not starting from scratch today, you will have a different architecture because you have history behind you, legacy, and so on and so forth. So I'm focused more on if we would start from scratch today, if we would have no history behind us, how we would do that. And most likely, no matter which tools we choose, we will do it in a very, very similar way as what I'm explaining here, in a very, very high level. And the first thing we need is a control plane of sorts, whatever that is, right? And the role of that control plane is to control everything, the whole system, right? Control plane is an old concept. If you use AWS, if you use Azure, if you use Google, you use control planes without knowing, right? That's how you send a request to the API and the system figures out what to do and where, right? So entry point to the system that will manage the whole system. Think of that as a control plane. And that control plane will be doing stuff. Will be applying resources to some Kubernetes cluster or somewhere else, right? Doesn't matter. It could be, maybe you're running in VMs, maybe you're using AWS Lambda, maybe you're using Google Cloud Run. Whatever you're using, that control plane will be managing those resources, right? And for us to work with those control planes, we need an interface, right? We need an API that you can go and say, this is what I want, whatever that something is, right? We've been living without APIs in this type of tools for very, very long time. Sorry, we've been living without APIs for a very, very long time. And I think that now we're at the edge that needs to change. We will have Git, meaning that control plane will get instructions from Git what to do. You will not be able to go and say, I want this. You will have to push to Git, right? That's the only reasonable way how we can track who did what and why and how and so on and so forth. There will be some databases, there will be some database schemas, there will be some secrets because some things you cannot push to Git. I mean, you can, but then let me know what is your repository. And there will be some graphical user interface, right? Graphical user interface can be anything. For some people, that's web UI. For some other people, that's VS Code. For third group of people, that's terminal, right? Some kind of interface through which you can interact with the interface, with the API of the control plane, right? So that's a short version, and there will be some pipelines, and there will be some people as well. That's it. So what I will try to do in 15, 20 minutes, more or less, is this, right? Control plane, user-friendly interfaces, synchronization from Git, using GitOps, schema management, secrets management, graphical user interface, and pipelines. Pipelines are shrinking in the scope of what they do, but they're still extremely valuable for one-shot actions, right? So I will skip the setup because I did that in advance, and I will start with the control plane, right? I will use Crossplane for control plane. Think of whichever tools I use today, think of them more as concepts, right? I need to use something to demonstrate something. You can accomplish similar results with other tools. So I'm not selling you anything today. And everything I'm using, except one, maybe two, is open source. Anyways, so Crossplane, right? Now, that's the first challenge. How do I create a control plane? How do I have an entity of something that will manage anything you want, right? And in this case, I'm using Crossplane. If I say get CRDs, everybody's familiar with Kubernetes these days, right? Lift your hand if you're not, and then leave. Okay? Now you wouldn't do it because you would be ashamed. So I'm running Kubernetes as a management control plane. I have Crossplane over there, and I have some CRDs. CRDs have custom resource definitions. Everybody uses CRDs, no matter whether you know or not in Kubernetes. That's how we extend the API with specific definitions of something, whatever that something is, right? And here you can see that I have, is this big enough? Can you read it? If not, move closer. You will see AWS resources. I can manage some things in AWS. I can manage some things in with traffic. I can manage some things in Azure, in Google, and stuff like that, right? This contains 200 more or less definitions with controllers that allow me to manage whichever stuff I want to manage today and more, right? So that's my control plane. It extends the API with everything I will ever have to do, right? So that's kind of the first, and you will see all that group together in action later, right? That's the first thing for my checklist. I have a control plane. Now, the second one is slightly more complicated, right? User-friendly interfaces. What I feel that many are still doing, and they're doing it completely wrong, is to say, hey, you need to run your application in Kubernetes. All you need to do is to define deployment services, ingresses, virtual services, and 57 other things that nobody but you understands, right? Same thing like if you need a database, if you need a Kubernetes cluster in AWS, all you have to do, dear developer, is to spend 7 years learning it. And after those 7 years, you will know that you need to create EKS and node group and internet gateway, subnets and VPCs, and nobody knows what else, right? A lot of things. So what I mean by that will not scale, right? You cannot shift left. You cannot enable people to do that, to manage stuff by using very low level resources, right? Because AWS is low level resources, and that's great because it allows us to do everything we want but you need to be specialized in AWS. The same thing goes for Kubernetes and other platforms and clouds, right? So what I'm trying to do here is to define new interfaces and say, hey, whenever you want to do this is how you do it. Forget about the details. I will take care of those details. And one way we can do that, for this demo, what I did is I created a couple of custom resource definitions of my own. One is called up claims and ups, and SQL claims and SQLs, meaning that whenever you want to define an application, this is the interface you will use. And whenever you want to run a database, this is the interface. It exposes everything you need to have, and it hides everything that needs to happen, but is not really relevant to you. And one example of that, and one great thing about Kubernetes, is that everything is behind the API. You can discover everything. You don't have to ask me how to do this, because you can just say, hey, explain to me what is up claims, right? And then you get a schema, and you see, oh, okay, this is great because I can define specification. It has some parameters, and those parameters have a database, for example. I can choose the size and the version, and I can choose the image of my application, and so on and so forth, right? Discoverable interface is very easy to define. And one definition of that, right? This is me being a developer. I would write something like that, right? If I want a backend application in my company with all the things implemented, I would write something like this. And this will differ from one company to another, because every team, every company has different needs. So I'm not saying that everybody should use this, but in this specific case, I'm saying, hey, I want a backend application with a database running in AWS. I'm selecting through labels which implementation of this interface I want. I will want to run it in a development namespace. This is the image of my application. This is the port. This is the host. And since I want a database, I want to have Postgres version 14 and medium size of the database. I have no idea what medium size is, but I do know it's bigger than small and smaller than big. Right? That's the important part of it. Now, I could create that application running in my Kubernetes cluster with everything needed, and database running in AWS with kubectl apply, et cetera, or Helm install, et cetera, et cetera, et cetera. Don't do that ever. We're going to get through a better way to do it. But what matters for now is that I created interfaces so that everybody can define things that are not their core competency, right? And the next thing we need to figure out, how do we do synchronization, right? Synchronization now by synchronization today, we don't mean anymore Jenkins executing commands like this or that, sh there and do this, right? Usually we mean GitOps, and by GitOps we mean usually Argo CD or Flux or Cup controller. And there is Rancher Fleet that if anybody uses, I would like to know. No offense. One. Actually, it's very good conceptually if you run at scale. Anyways, so I will use Argo again, just because I need something. And the first thing I need to do is to install Argo, right? So I'm just going to execute Helm upgrade install Argo. This is the chart, right? And by the way, this is the first and the last time I will do anything like this. This is the first and the last time I will execute Helm command or kubectl to define what I want in that cluster. The first and the last. That's the important part, right? It will take probably a minute or two until that is finished. Once it's done, I will have Argo CD up and running. Now, if it takes more than 5 seconds, you can blame AWS. And I know at least one person here to whom you can throw stones. No? It will be done soon. By the way, whenever there is a pause like this, forget about the pause. Here's Argo CD. And I can prove that I'm not lying here, but opening it in browser. And you can see that Argo CD is up and running. It doesn't have anything, right? Now, from now on, it will be monitoring some Git repositories, and it will make sure that whatever we define there is in my management cluster. And that management cluster control plane has the role to propagate it further. Oh, you wanted AWS? Go there and do something, right? Or whatever that something is. Now, for Argo CD to work, we need to define application and project. I will not waste time showing you the manifest. I will just explain that application in Argo CD means that's the repository, that's the directory, go. That's all it does, really. And you can see here that, there we go, right? I have two applications now, production infra, production apps. They're monitoring Git repositories and they're waiting for me to push something over there, right? So cool, so far so cool. I figured out how to synchronize, how to manage my system, right? And I'm gonna manage it by pushing things to Git, period, nothing else. Now the next thing I need to figure out is, there are some things that I cannot push to Git, right? That would be silly. So I need some kind of, no, this is wrong chapter actually. Ignore what I said, schema, right? I will have database up and running. I already showed you the definition that will ultimately deploy application database. I need to figure out how to manage schemas of my database. How to use SchemaHero. SchemaHero is probably the best tool you can use to manage schemas in Kubernetes, and it's horrible. Absolutely horrible. It's the best because it's the only one. Anyways, so how do I deploy SchemaHero? Very easy. From now on, I'm not touching Kubernetes, not touching, right? I'm going to copy some YAML to the directory infra over there. I will copy and paste those commands because I'm too lazy to type, and I will push it to Git, right? Copy to the directory, push it to Git. That's all I will be doing now, right? And if you go here to infrastructure, you can wait. It takes, by default, up to 3 minutes for Argo CD to synchronize. You can change that period of time, or you can click the refresh button, and you can see, oh, I discovered something in that Git repository. It's called SchemaHero. I'm going to manage it, whatever that is, and automatically it deployed SchemaHero, or it is deploying it, or it will be deploying, whatever, right? But I figured out how to manage schemas of my database. I did not put it yet together, but I'm getting there, right? Now I'm coming to the secrets that I mentioned before. I will keep them in AWS Secret Manager, or whatever it's called. I need a way to pull them from there and put them into my management cluster, and from there on it will propagate wherever it needs to propagate. And this is becoming now too easy, right? You define YAML. I can even show you YAML. It's very, I cannot show you like that. I can do, right? I just define YAML, say, hey, Argo CD, there is a chart, Helm chart in this case, in this repository. This is the version I want. Those are the values, and I will push that to Git, right? Here we go. Git add, Git commit, Git push it to Git, and from now on, my cluster knows how to manage secrets. It does not know yet how to manage it in AWS. I did not get to that part, but secrets in general. And if you go back to Argo CD, you can see, where is it? Infra, refresh, it detected external secrets, there it is deploying it, right? Now, for secrets managers, for external secrets operator to work, you need also to tell it how to contact your secret store. You can see here that I'm saying, hey, I want to use AWS, that's where my secrets are. This is the secret with the access key ID and secret access key. I will not show you that secret because I'm not that crazy. And this is how you connect to AWS and manage secrets. What do? I copy this to the directory infra. I git add commit push goes, right? From now on, I'm not touching my system. So I'm almost there, right? I know I have a control plane that manages everything, including AWS and Azure and Google and other Kubernetes clusters. I have interfaces, meaning APIs. I have synchronization from Git with GitOps, schema management with SchemaHero, and secrets management with external secrets operator, right? Two things missing. First, graphical user interface. That's the part that has two requirements. Any graphical user interface has two important requirements. First, to have very pretty colors. If it's not colorful, not good, no bueno. Second thing, buttons, right? And for that, I will use Port today. Port is a service It's very cool. My preference over backstage, we can fight over that, but not now. And port is where I will combine all that together. And the first thing I need to do is to tell port, I will copy this, to tell port, hey, there is something that is called cluster. So this is defining schema. This is defining how it will be presented on a screen. And I'm saying, hey, I would like to have something called environments, you know, production environment, staging environment of what's or not, right? And you will deduce what they are based on the clusters where something is running. So I will go to port. This is port. Hey, say hello to port. There we go. I will say add custom blueprint. Whenever somebody wants to use something called environment, here we go. This is the schema for that, right? And you will see if you're very quick that somewhere, there we go. Oh, there we go. Environment appeared over there, right? You see it in the middle. So I want to enable people to deploy things to a certain environment. I want them to manage their backend applications, right? So I need one more blueprint, which I conveniently already prepared in advance. And that one is going to say, hey, this is the blueprint for a backend application. It has some properties, like this is the URL of the Git repository, this is the language, and this is the list of all the acceptable languages right now. And you have the host and database version and size and so on and so forth, right? Things that matter for developers when they work with backend applications for a database, whatever you define that something to be. I will copy that. I will go back to port. I will say, give me a blueprint. Oh no, create a blueprint. There we go. And you will see that it appears next to environment. This user interface is horrible. Backend application there. So there is one-to-many relation between backend applications and environments, right? So, and environments are related to clusters. So one cluster can have one or more environments, and in each environment we can run one or more applications. Cool. Now, there is, I don't know whether I defined this. Yeah, I have it. Okay, cool. I will do this. This output contains my password, so please don't read it, otherwise I will have to change it later. What this huge, hard to read YAML really does is that I will deploy to my management cluster, and it will discover what is running there, and it will feed the data to the user interface, right? So whatever I do in my cluster, it will be fed to that graphical user interface. That's what basically I'm saying, hey, whenever you, let's find the one example, whenever I discover something called backend database in AWS, those are the fields of the schema in port, feed the data there and show it to my happy customers. So I'm going to deploy that to my cluster by pushing it to Git. Again, not doing anything directly in a cluster. Cool. Now, there is one last thing missing, right? From now on, whenever I deploy something, I have a nice API, and it will be auto-discovered and shown in the graphical user interface. The thing missing is actions, right? How do we create the application in the first place? Because creating applications is different than visualizing application. I will use GitHub Actions for that. And to do that, I will here copy this. Basically, I will tell port, whenever you click a big button, pass take those properties, pass them to GitHub Actions, run some script, and the repository will be created and it will be converted from templates to something else and so on and so forth, right? So I'm going to go back to port. I'm going to here go to backend application. I'm going to go to actions, and I'm going to say edit JSON of the actions, copy, paste, not that. Paste, there we go, right? And I'm done. Took 20 minutes, give or take, right? Now, the only thing really missing is two things. Those pipelines, I said, right? Who doesn't know what is GitHub Actions? Everybody. Okay, no need to show you in the interest of time. I have 7 minutes. Basically, okay, let me show you quickly, actually. What I'm doing in GitHub Actions is very straightforward. I have some parameters. and then I will just execute a script that will create a repository, and then I will execute another script that will create Argo CD application and push it to Git, and I will push all that back to Git. Very easy, straightforward, nothing special. Takes 5 minutes to create. And that's all, right? And now I want to see it in action. And to see it in action, I'm going to do this. Now I'm a developer, right? I'm going to self-service, right? And I'm going to click a button. Let me make this bigger for you. There we go. Create, right? I said, actually, this is a complaint to port. I've only pretty colors. There is only blue and white. Unacceptable. Anyways. I'm going to call this new repository IDP demo, what did I call it? Yeah, app. IDP demo app. This will be the name of my application. It will be accessible through, I don't know, Madrid.com. No, acme.com. Right? This is the database version I want. This is the size. Medium sounds good. This is the environment where I want to run it. There is only one because I didn't do much. Execute, right? And this is everything I expect from people. And as a result, two things will happen. New repository is being created right now as I talk. That repository has a separate set of GitHub Actions that will build an image, run tests, push that image to registry, do everything that needs to be done. And when it's done, it will push. You remember that Git repository where I was pushing so far things? It will push a new definition of the application. That will be discovered by Argo CD. It will be, and it will be applied to one of the clusters, whichever cluster. And the credentials for the database will be created in AWS, and the credentials will be fetched from how to do that will be fetched from Secret Manager, right? Now let's see whether that finished. It takes a while, so not yet here. You can see here that this interface is dynamic, right? After I created environments and backend apps, they appeared here. Right now there is nothing. There are environments, right? You can see production and staging. They were discovered. There are different namespaces, but backend apps are not there yet because it takes probably 5 minutes or something like that until all the worlds collide and all the stars align and all that stuff. If I go back to Argo CD, let's see whether it's discovered. Production apps, it's not there yet. There we go. That's coming from the newly created repository from a few minutes ago, a minute ago, something like that, right? And if I go to the cluster, you can see here, app claims. This is that interface that I created for my developers for backend applications. It's already synchronized. What else do I have here? Low-level details. So this is developer-facing interface, right? It's very easy, only the things that matter. Now, if somebody wants to see the details, that simply YAML created some secrets and ingress and stateful set. For that stateful set is for the SchemaHero and replica set that created by deployment and service and pods and all that stuff, right? Things that are low-level details, not really matter too much. Now, what is interesting is that you see the first pod, it says error image pool. It cannot pull the image yet because it wasn't pushed yet. GitHub Actions did not finish building it and pushing it to registry. And even when it does finish, it will continue failing for other reason because after that, it will discover that there is no secret how to connect to the database because it takes like 5, 6, 7, 8 minutes to create it in AWS. Now, speaking of AWS, if I do get managed, this is now Crossplane. You will see that those 10 lines of YAML, apart from creating resources in Kubernetes for what's or not, for the application like Ingress and SchemaHero and this and that, if this ever wakes up, you will see which resources were created in AWS eventually. There we go, right? You can see that behind that something that the implementation is that, hey, I created a subnet, I created the RDS in AWS, I created a database inside of that server. Those are the resources of the application itself. There is a VPC was created and some subnets and security group rule and route table and stuff, right? You don't care. I mean, you do care if you're on an admin side. You don't care if you're on development side. And eventually, I don't have time. Hey, there we go. It appeared. That's now, this is actually what you would be seeing as developer. After clicking that button, waiting for a couple of minutes, there is your application. There is all the interface, all the information that, and this is all custom, right? None of those things come out of the box, but we spoke and we decided that this is the information that they should see in the graphical user interface. And you can see that this application is related to the production environment, and it is living in this cluster, and so on and so forth. And I have 1 minute for questions.
Where have we deployed?
Yell!
Where have we deployed this port application?
Where do you deploy port application? Port application is SaaS solution right now. They're working on self-managed. Port is SaaS. So you cannot see the address, but it's app.getport.io. They're working on a self-managed version of it as well.
So the Kubernetes is basically registered to this port application.
I honestly don't hear you.
Sorry, I mean the Kubernetes clusters that we have spinned up is getting registered to this external SaaS application.
Yeah, so port is just visualize. It has only two things. Define the schema of something, whatever you want. Tell it how to get data for that something. In my case, it's getting it from Kubernetes. And define the actions, the triggers, actions. I want new application. Port does not know how to create a new application, but it knows just how to send a request somewhere, in this case, GitHub Actions. So it's a relatively dumb, customizable user interface. Behind that, there is Kubernetes. Inside Kubernetes, I'm running Crossplane that allows me to communicate with AWS this or that. Argo CD to synchronize with Git. A few other things I forgot already. Anybody else? It's fun.